All right, so let's go ahead and let's add in another item here. So let's add in an A cylinder. All right, and we all know what cylinders are, but let's go ahead and let's take a look at. Let's just take a look here and let's actually make one first. Okay, so let's. And one thing you can actually do is, if you really wanted to, you could in theory, just copy this and paste it over here. Okay, and as you can see, what that would do is that basically puts it in the middle here. Now, another cool tip that you can use is you can add in the wireframe. So I'm just going to add that to my box. So I'm going to say, and wireframe basically puts it as the wireframe, because if you look very closely at this at this box here, this is exactly what is being drawn when it comes to 3D surfaces, right? We basically have these we basically have vertices, lines, and faces, right? And this does not render anything. It just shows you kind of the lines and the vertices. So you can do that if you're prototyping, which I think is pretty good. And of course, this works with everything. So if you wanted to do wireframe here as well, is equal to, you can say that equal to true here. You can see that cylinders have a lot more frames in them. Okay, so there we go. So let's take a look here just at the cylinder. And this cylinder is looking pretty good here. Now there's a few things that you need to understand about cylinders. You can add in a height. So let's say it's 2 meters, 1 meter, 0.2 meters. You got kind of a disc going on there. So let's just keep it at that for now. And then the radius here. Now the radius is, of course, is how big this circle is in the middle. And the radius is 1.7. You can make it bigger. You can make it, smaller, like so. You can make it as big or as small as you want. Let's just make it 1.2 for now. So, like, basically the same kind of thing here. Okay. Now there are other kinds of cylinders here. Okay. So what I'm going to do is I'm actually going to copy this wireframe in here and paste it in here. All right. And let's go ahead and let's add in another cylinder here. But I'm going to remove the wireframe. Okay. And then I'm going to be talking about a different kind of cylinder. Now, in theory, a cylinder is a circle. And if you look at the wireframe and you zoom in close, each circles aren't exactly like a circle as you would draw them. They're actually a circle with many different sides. So we can technically make a hexagon base, and that will make what kind of cylinders are a little bit more clear. So let's go ahead and let's just kind of delete this here for the time being. And let's actually move this up here. Actually, let's move it down to 0 so we can kind of see it a little bit better. Okay, so we now have, well, it's basically the same thing, but we're going to do the segments, and it's going to be radial. Okay, so we can add in this radial segments here, and we can make it a pentagon. So let's say it's 5 here, and you can see that this is kind of quote unquote a cylinder. But this is the way that computers draw cylinders, is they draw a bunch of sides and then faces going down. So for instance, let's say if I did 40, you can see that it's now a cylinder. Okay, so if I just do this, like 5, 6, 7, 8, 9, we still don't view this as a cylinder, as in kind of a round disc. But once we get up to like 13, you can start to see that this is becoming more and more like a cylinder. And if you've ever seen low poly games, this might actually pass as a cylinder maybe 25 years ago in a 3D game engine when 3D games were just coming out. So you can see that as soon as we get to 25 sides, this looks like a cylinder. And if we put in the wireframe, right? So if you look at the wireframe here, and the wireframe, will make that equal to true. You can see that this is basically a bunch of sides here. Now, when it comes to sides and when it comes to sides, the more sides and faces and vertices and lines that you have, or edges that you have, the more computing power it's going to take. And this is something that's really important for you to understand. Now, nowadays, phones are extremely good. In fact, your phone is so much more powerful than game consoles were. Pick a point in time like 5, 10, 15 years ago. Your phone is probably better than a lot of these game engines, which is quite impressive when you think about it. That something that used to sit on your desk is now powerful, or something that sits in your pocket is more powerful than something used to sit on your desk. And this is just the way computing works. Now, specifically, one thing you always have to be cognizant of how many faces and how many geometry that you're putting in. And that's what they call it. They call it geometry. So the more geometry you have in the scene, the more computing power that's going to be. More faces, more edges, more vertices. All this equals more geometry. And the more geometry you have, the more chance you have of lagging. So you don't want to go overboard with this. So what I'm saying is that if you had a radial cylinder with 250, and you can see the wireframes in here, that takes so much more computing power than this does. Now, what's interesting, and this is just absolutely amazing for someone who's been coding for a long, long time, is like this, the fact that this scene has absolutely no lag on the web is incredible. Now, of course, we can go one step further, and you can see that now this looks like a solid here, and now you start to see it lag a bit. And I think if I were to, this might actually crash. If we did this here, yeah. So there you go. Now it starts to lag really bad. This is way too much geometry. Okay, way too much. So you never want to do this. And I'm just going to delete that here because I'm afraid that my computer is going to crash, and that's another reason why, or it's one of the reasons why, if you're working with 3D software, computers crash it, because it has too much. It's trying to compute too many things, because really, at the end of the day, you're still computing this, right? Like this, even though it's being drawn and rendered, a computer is computing it at its base level. So one of the reasons why computers crash is that you fill up the memory with too much information, or the processor gets overloaded, and that's something you can do. So as you can see, we can simply put in, and even, by the way, you basically have a cube. If you put to 4 or 3, you have a triangle here, or you can make something like a pyramid here. But as you can see, if you wanted to add in like a hexagon, you can go ahead and do that. Okay, so let's go ahead and let's copy this here, and let's say false, and let's move this up to 3 here. So now we have, or maybe make it 2.5. So it's just kind of up there. So now you can see that we have these different items that we're kind of looking at here. And while we're at it, let's color code these. So let's make this blue. Let's make this cyan, and then this can just be orange for now. Right, and then this first one actually will be red. So you can basically see that we're doing all these things here. So the other thing that you can do is you can add in a pipe. Okay, so let's just go and get rid of this here. And by the way, you can add in the segments radial to any kind of cylinder, but you don't have to. If you don't need it. So the way this works is that for every single kind of property that you're making, or any kind of item that you're making, you can simply add in as needed. Like if you don't need the wireframe, you don't need to put it in there. Okay. Now, some programming languages require you to do this, like and specifically older programming languages. And of course, HTML is not necessarily a programming language. If you want to get into semantics here, but like when you're thinking about older coding languages, sometimes if you wanted to put in a cylinder, they would force you to put in all the properties. HTML is not like that. You only add what you need. Okay. So if you don't need the wireframe, you simply don't put it in. All right, so the next thing that we can do is we can type in open-ended. Okay, and then this is a true or false here, or it's a Boolean, which means that it's simply true or false here, and you can just simply add that in here. Okay, so let's see, and let's just get rid of this height here. So we'll just simply do that here, and you can see that it's just at this point, it's just basically the top here that has been deleted. Okay, so, and this is actually kind of hard to see at the top here. So if we kind of move this down to, 1, right, or 0, you can see that it's essentially just open-ended.